Have you ever been in a quiet room when suddenly you hear it? A strange, high-pitched whistle. It seems to come from nowhere. But then you realize it's the wind, sneaking through a crack in the window or a gap under the door. How can invisible air make such an eerie sound? Let's break it down. Wind is simply moving air, and air is a fluid, just like water. When it flows past objects, it behaves in surprisingly complex ways. At low speeds, air moves smoothly in layers. We call this laminar flow. But as wind speed increases or encounters obstacles, like a building, a tree branch, or a narrow crack, it becomes turbulent. It swirls, spins, and creates small spinning pockets of air, like tiny whirlwinds. Now here's the interesting part. These turbulent movements can make the air vibrate. And when something vibrates, in just the right way, it creates sound. So why do some cracks whistle, while others stay silent? It all comes down to shape, size, and speed. Imagine a bottle. If you blow across its top, you hear a tone. That's because you're creating a resonant frequency. Air passes over the opening and sets the air inside the bottle into vibration. In a similar way, when wind passes over or through a narrow opening, like a gap in a window or a crack in a wall, it can act like a musical instrument. The air is forced through the small opening, speeding up and creating pressure differences on either side. That causes the air inside and around the gap to vibrate at a specific frequency, producing a whistle or hum. These wind noises come in many forms. A whistle from a keyhole, a low moan from a chimney, a howl between two buildings. Each sound is the product of the wind's speed, the direction it's coming from, and the shape of the opening it's interacting with. Sometimes, when wind flows over rounded objects like wires, cables, or even branches, it can create something called a Kármán vortex street, a repeating pattern of swirling air. These vortexes can alternate pressure on each side of the object, and if this fluctuation happens at just the right frequency, it can excite vibrations in the object, or in the air itself. And that becomes sound. In fact, many of the wind noises we hear around buildings are accidental instruments, like wind flutes. They weren't designed to make sound, but the laws of physics say otherwise. Let's go even deeper. Why do we find these sounds so unsettling? It turns out that our brains are highly sensitive to certain frequencies, especially those that fall in the range of human speech or a baby's cry. High-pitched whistles or sudden whooshes of wind can trigger a kind of alert response in us, even if we know there's no real danger. They break the silence. They feel unnatural. It's as if the environment itself is speaking, or warning. In some cultures, these wind sounds have even inspired myths and superstitions. People once believed that howling wind meant spirits were nearby, or that whistling at night could invite bad luck. And honestly, when you hear a low, ghostly moan echoing through a window pane in the dead of night, can you blame them? On a more scientific note, engineers study wind noise carefully, especially in car design, architecture, and even spacecraft. Tiny changes in the shape of mirrors or door seals can drastically reduce unwanted wind noise in a vehicle. In buildings, better insulation and tighter seals help prevent not just heat loss, but whistling windows. Even the layout of cities and skyscrapers is designed with aerodynamics in mind to prevent intense wind channels and resonance that could produce audible noise, or worse, structural stress. So next time the wind whistles through a crack, don't just reach for the tape. Listen closely. You're hearing physics in action. It's the sound of pressure, turbulence, vibration, all orchestrated by nothing but moving air and solid surfaces. It's nature's accidental music, and all it needed was a tiny gap in your window frame. Like sounds like this one? Subscribe for more brain-tingling science, and let us know, what everyday mystery should we explore next?